Okay, I'm gonna do another linear programming problem here for YouTube. This problem I'm doing because it has a couple nuances that sometimes students have problems with when they're learning linear programming. So I got this problem. I didn't get this exact problem, but a problem like it. There's a problem very close to it in this book. This is a very good book that I use for teaching quantitative methods and at RSU. And so I'm going to use, so that's just to let you know, this is where I got a problem very similar to this from this book. Okay, so by the way, it's a good book. So let's see. Let's just get in here and do the solution. I guess I should read the problem before I do the solution. So what do we have? We have 30 stores, and currently the employees at these stores, we have 85 employees. We have 85 employees that are cashiers and 175 workers. So I guess by the workers, they might be people that are stocking the shelves, working in the warehouse, or whatnot, right? We forecast, management forecasts that we're going to need at least 250 employees totally. So if we highlight these two and look down here, they already have 260, but they're saying we need 250. And they also know from history that they're going to have at least 10 of their employees that they have right now leave, and they're going to have at least 30 of their workers. 10 cashiers and 30 of your workers are going to leave. So then they also forecast that they need to hire at least 15 cashiers. So I guess they're taking that into account, right? They have this right now. They have this many leave. They think they're going to need to hire, 15 more, taking this into account. It's a little bit circular thinking, but that's kind of the way I'm looking at it. That this is what you have. This is your leave. So taking this into account, we need to hire at least 15 more. And then for quality, you can only have the more. I guess they don't want to have too many workers per cashier, right? So their ratio of worker to cashier, they want to have no more than 2 workers for every cashier they hire. Or maybe they have a reason, the cashier maybe can go back and help a worker if they have to. I don't know. Anyway, that's what they're just saying. No more than 2 workers per cashier. And then the salaries for the cashiers and the workers. And we want to find a minimum cost plan for the number of employees and hiring recommendations. So basically, how many workers and cashiers do we need? All right, so this is perfect for linear programming. And the first thing you want to do is you want to declare your variable so you can say what letters are what, right? So let's just say the number of cashiers. We'll call that, let me stretch this out a little bit. We'll call that the letter C. And we'll call the number of workers. We'll call that the letter W. All right, so next thing we want to do is we want to so now we know from now on, whenever we see the letter C and we see the letter W, we know that stands for the number of workers and that stands for the number of cashiers. So let's just start doing we'll do our objective function first. So we could say, so I'm going to put, I guess we'll put C here and capital C. Capital C here, capital W here. So we'll say 1 times the number of cashiers plus 1 times the number of workers. Well, we want to, it's not 1, right? Well, let me do it this way. I'm sorry, I'm not awake this morning. Equals, the salary for the cashiers is 25, right? And then here I'm going to go equals the salary for the workers is 15. Now look, I'm actually relating it back to this, right? So if I go and change my assumptions, it's going to change things automatically down here. And so here we want to minimize this because this is salary, right? So this is a cost. right? You want to, in a business, you want to minimize your costs, so we want to minimize this. So this objective function, so $25 times the number of workers plus $15, or $25 times the number of cashiers plus $15 times the number of workers is going to equal my total salary, right? And we could say, you know, just working for 1 hour, right? It doesn't matter if you say 1 hour or 40 hours. Just say for 1 hour of them employed, that's what it's going to cost. All right, so the number of employees is a constraint. So we know from up here they need to have at least 250 employees. So you could say 1 times the number of workers plus 1 times the number, or 1 times the number of cashiers plus 1 times the number of workers. Well, that has to be at least greater than or equal to, and I'm going to go here, I'm going to go equals 250. So now I have that. Let me kind of center this so it looks a little nicer. Okay. So now so 1 times the number of workers plus 1 time, or I keep saying cashiers, or workers instead of cashiers. 1 times the number of cashiers plus 1 times the number of workers. That's going to be your total number of employees. That has to be greater than or equal to 250. And the next constraint they have here is a quality constraint. We'll put that in. So quality. And so this one's a little bit weird. It says no more than 2 workers per cashier. So how are we going to put this in? Well, we could say, oh, I'm going to do it this way and it'll make sense in a second. I'm going to do it over here to the right before we put it in down here. Let me just do it kind of like right here. So I can say 1 times the number of workers. Well, let's see if this works. Is less than or equal to, I've done this enough times so it's kind of counterintuitive of what you think. So this is my equation. If I'm coming up with an inequality. First you got to write an inequality and then you got to rearrange it and put it over here. So let's plug it in here. 1 times, so so it says, let's think about this way. I'm writing this equation because I know, because it's counterintuitive, but I've done it enough times that I know how to do it. But just let me show you why it's right. So let's look up here. It says, for quality, it says no more than 2 workers per 1 cashier. So let's plug in 2 here. So 1 times 2 is 2 is less than or equal to 2 times 1, right? No more. And we want this to be smaller than this. That's what the no more makes. So 1 times the number of workers, which is 2, has to be less than or equal to 2 times the number of cashiers. In this case, we would have 1. Well, this always has to be, this side has to be smaller than that, right? So I'm having a hard time explaining this. Trust me, you got to do it this way. You have to kind of reason it out, right? So if I plug in 2 for W and 1 for that, well, that's what I have here, 2 and 1, right? But we know that the number of workers has to be, this could be 1, right? So I could have 1 worker and 2 cashiers, right? That's okay, but I couldn't have a 3 in here, because if I had 3 workers, then my ratio would be wrong, right? It'd be 3 to 1. And this would not be less than or equal to. So this has to be less than or equal. Hopefully that makes sense. I know I'm not explaining it very well, but you're going to have to reason it out on your own how to do it. So the next thing we want to do is we need to rearrange it. So let's subtract 1W on each side. So I'm going to do apostrophe minus 1W. So now, and then there's a 0 over here, right? So I just rearranged the equation. So I took this over to this side, subtracted 1W on each side. And then let's just flip the whole equation. So now what you have to flip the whole equation. So this has to flip also, right? Because this is pointing towards 0. So it'd be right. So I just flipped the equation around, You got to make sure this is pointing in the same direction. See how the arrow is pointing towards the 0, so it has to point towards the 0. I just flipped everything. So now I can plug this in here. So now we have 2 and a minus 1 is greater than or equal to 0. So this is kind of tricky. Hopefully you can reason that on your own. That's one of the reasons I want to do this video, just to show you how to do that. And I don't think I explained it very well, but hopefully I explained it well enough that you can understand what I did. All right. So now we have the quality constraint in. And another thing, as I said, so now we got to worry about the new hires on the cashier side. So you can say cashier hires. Cashier hires constraint. So we can say 1, and they're just talking about cashiers, has to be greater than or equal to. So I'm starting out with 85. So let me put it here. So I'm going to go equals 85. And I'm going to lose 10. So I'm going to go minus 10. And I have to hire at least 15. So we know that has to be greater than or equal to 90. Okay. And also we could say, we know that these two, we can't hire a negative amount. So this is greater than or equal to 0, and this is greater than or equal to 0. Right? It could be 0, but nothing. You can't hire negative workers or negative cashiers. That kind of goes without saying in this case. You're sticking to the positive quadrant. If you're talking about, if you're graphing, if you graph it in algebra. Okay, so now we're ready to solve it. So this is probably the hardest thing, is just kind of formulating this. And probably in this problem, this is probably the most difficult to try to understand that. Everything else is pretty straightforward. So I'm going to do part A. And I'm going to show you how easy this is to do in Excel, and you're going to really appreciate this. So I'm just going to highlight these. So I have to set the problem up first before I do it in Excel. I'm going to highlight that. And then I'm going to take these. I'm going to copy them just here for reference. And then I'm just going to go equals. I'm going to copy these here for reference also. And I want to make a guess, so I'm just going to guess down here. I'm going to go C and W. And let's just say 75 and 150. I have no idea. I don't know what these are. I'm going to make Excel figure it out. Whoops. But I'm just going to put a number here for now, but later on we're going to make Excel adjust this number to satisfy these constraints up here. Alright, so here's the part that's a little bit weird. I'm going to highlight. So I'm going to highlight right here where I want my answers. Okay? And I'm going to start typing. I'm going to go equals M multiply. And I want to multiply all these numbers up here times the transpose of these two variables that I have here. Close the parentheses twice. I always spell transpose wrong. Even though I know I do it, I still do it. So I guess before I hit Control Shift Enter, I'm good. So now instead of hitting Enter, you have to hit Control. You hold down the Control key. It'd be CTRL on your keyboard. Then hold down the Shift key, SHIFT, and then hit the Enter key. That's going to do it for you. So whenever you're doing a matrix formula like that, you have to do it that way. All right. So now if I change this, like if I change this to 100, it's going to automatically update these numbers down here. So I can sit here and guess until I minimize this. Play the hot and cold game, guess between these two variables, change these numbers. But we can make Excel do it. So I'm going to go to the Data tab, and you should have Solver here. If you don't have Solver, you have to go to File, and then Options, and then Add-ins, and then go to Go, and you have to click the Solver and go OK. I'm not going to click and go OK because I already have. You're not going to have that showing. Solver. If Solver is not here, that's not going to be clicked. You're going to click that and go OK. I'm going to cancel because I already have it. So then we're going to Solver, and I want to set my objective. So I just told you this is the objective, right? So this $B, $31. I want to minimize that because it's a cost. And what I want to, and this is by changing variables, well, I want to change these two variables. So I want to add some constraints. I want to say that this is greater than or equal to this. I'm going to add another constraint. I want to say this is greater than or equal to this. Add another constraint. I want to say this is greater than or equal to this. Then we go OK. Make sure this is checked because that makes sure that this is satisfied, that we're staying in the positive quadrant. And then we'll just go ahead and use like simplex because this is linear, simplex linear programming. And I'm going to go solve, go OK, and you'll see that it changed it down here. So this is my answer. So this is how many cashiers I need, and this is I want to have employed, and this is how many workers I want to have employed, and the cost for 1 hour of employing those people next year will be $4,650. All right. So B, we want to do the staffing recommendation, right? Hiring recommendation. Let me just go equals B. I don't have to type it again. And I'll go C and W. So how many people do I want to hire? Well, I need 90, right? So it's going to be equal to 90. Well, I already have 85, right? Oops, let me start that again. Equals 90 minus the numbers we're thinking about how many I have to hire, minus the number I already have, right? They want me to hire 15 more, so plus that, and then let me think about this. So 85, and then let me think. Hold on, let me think about this. I need 90, and I started out with 85, and I lost 10, so now I'm at 75. I'm going to hire 15. So I'm going to have to hire 15. That kind of makes sense, right? Because they told you have to hire 15. So basically this equals the same thing.
I didn't understand that.
So that's basically the same thing. It's going to be equal to, well, it's just basically equal to, that makes sense, right? It's equal to how many they tell you they want to hire. You're going to hire 15, at least 15. And let me think. I'm not awake this morning. I know it's 15. I'm just trying to see how I can explain it to you better. So I need 90, right? That's what this says I need. And we had 85, right? We lost 10. So 85 minus 10 is 75 plus 15 is 90. So that works out, 15. Yeah. Well, hopefully that makes sense. The number of workers we need, well, we need 160. We started out with 175. So I would go equals, well, I need 160. I started out with 175. And then I lost 10. So I'm going to go minus 10. Here I lost 30. So I'm going to end up with 145. So I need 160. So I'm going to take 160 minus that. So I need 15. Okay, so that's my answer to the number of workers I need. All right, so I know I explained some of that stuff kind of strange. I'm just not awake this morning. Usually I do better at these videos, but you're going to have to try to maybe rewind or think about it on your own a little bit on some of this stuff. Anyway, I think the key is Excel makes it pretty easy with a solver. As long as you set it up the way I showed you. Remember, this is This is the formula to put in these 4 numbers. You have to highlight. You have to highlight all this, and then you type in this. To get these little curly brackets on the outside, you have to hit Control-Shift-Enter. Okay. Put the formula in here. What else? I think that's about it. Hopefully that was helpful. If you like my video, I'll have a little picture up here. Click on that picture to like it or to subscribe, and then if you like it, do me a thumbs up. Give me any comments you'd like. I'll go ahead and I'll try to put a link to this Excel spreadsheet in the description for the video. All right, so thank you. Bye bye.